Hello students, so today I will tell you the protection of 1,2 and 1,3 diols as a cyclic acetals. So we can use various reagents to convert 1,2 diols or 1,3 triols in a cyclic acetals. So first of all, let's see 1,2 diols. 1,2 diols. Okay. So let's summarize the different ways by which we can convert this into 1,2 diols as a cyclic acetals. So protection as we can protect this 1,2 diol as a 2,2 dimethyl acetal. Okay, so this is one of the way. So this is given number 1, and for this the reagent that we will use, reagent used is acetone may be used. Acetone in presence of acid catalyst. Okay, and for deprotecting agent, we may use a concentrated HCl or H2SO4, or we may use para-toluene sulfonic acid, PTSA. We can use a PTSA, para-toluene sulfonic acid. So this is one of the way, and that 1,2 diol can be converted into 2,2 dimethyl acetal. So if I have, suppose, if I have, this is 1,2 diol. Okay, so by reacting it with a acetone in acid condition, that would be converted into 2,2 dimethyl cyclic 2,2 dimethyl acetal. Okay, so this is cyclic acetal or 2,2 dimethyl cyclic acetal. One of the way by using this acetone. Another way that we may use 2,2 dimethoxy. 2,2 dimethoxy propane can also be used. That is called as a DMP. Dimethoxy propane can also be used. Okay, so the structure for this dimethoxy propane, this is propane, and this is 2,2 dimethoxy propane. Or we may use 2-methoxy propene can also be used. 2-methoxy propene can also be used. So structure for this 2-methoxy propene. Okay, so this is 2-methoxy propene. So this is one of the method. This is one of the method that 1,2 diol can be converted into cyclic 2,2 dimethyl acetal. Another way that we can convert this 1,2 diol into cyclic carbonate. We can convert into cyclic carbonate. Okay, so the structure of this cyclic carbonate is cyclic carbonate. So how can we convert this into cyclic carbonate? By reacting it with a phosgene. If we have a, suppose, phosgene, by using phosgene in presence of this pyridine, this is phosgene pyridine. So for this, the deprotecting agent that we can use is KOH. In methanol can be used as a deprotecting agent. So 1,2-diol can be converted into cyclic carbonate, and another was the 2,2-dimethyl acetal. And third way, we can convert it into cyclic silyl acetal. Cyclic silyl acetal. Okay. So for this, we can diol that can be converted into, this is, okay. So silyl acetal that can be converted by using tertiary butyl, ditertiary butyl silyl chloride. And for this, some fluoride source is used. To break this silicon oxygen bond, we should have some fluoride source. It may be TBAF, or we may use HF in acetic acid can be used. Okay, so this tetrabutyl ammonium fluoride. So this is TBAF. Another way that we can convert into cyclic boronate also. Cyclic boronate. We can convert 1,2-diol into cyclic boronate. This is boronate. And for this we may use a boronic acid. Boronic acid. Reagent used is boronic acid. And the deprotecting agent that we can use is your propane triol. Propane triol in benzene, it can be used for deprotection. Okay, so this is the brief for the protection of 1,2-diol. So let's see their mechanism one by one. So first one, that is protection as 2,2-cyclic 2,2-dimethyl acetal. Okay, so how can we convert this 1,2-diol into 1,2-diol? So how can we convert? I told you, if we have 1,2-diol, so this on reaction with this acetone under acid catalyst. So suppose if we have acetone, then in presence of this acid, so this oxygen that is protonated here, and this will generate a strong electrophilic center over here. So if we have a diol, then this oxygen as a nucleophile, it will attack over this electrophilic center, and we can write this OH. So this oxygen will have the positive charge over here and this OH. Okay, so in next step this proton transfer will occur. In next step proton transfer will takes place and it will be converted into OH2 as a H2O as a good leaving group, and so H2 that is removed. First of all, this positive charge that will be created and we will have a positive charge over here and H plus is removed. The catalyst is removed in the next step. Okay, so we have a dimethyl acetal. So this is dimethyl acetal, cyclic acetal. So when 1,2-diol after protection, 1,2-diol after protection, it forms a 5-member ring. That you should remember. 1,2-diols after protection form a 5-member ring. Okay, and 1,3-diols after protection it forms a cyclic 6-member ring. Okay, so this is the method of protection. Now let's see the deprotection. Let's see its deprotection. So deprotection. So if we have this cyclic acetal, and as I told, this can be deprotected in presence of concentrated acid. So here this is protonated and this carbon oxygen bond it will cleave, and what we will have? We will have positive charge over here and this is OH. So we have got one of the OH of diol has got, and we have to develop another OH over here. So in another next step, this H2 as a nucleophile will attack. Okay. So okay. So next step we will proton transfer will takes place. This should diol plus and we will have the acetone there. So this is the mechanism for protection and deprotection. So what we have seen, the conversion of 1,2-diol into 2,2-dimethyl acetal. In the same way, if we are using in place of acetone, suppose if we are using 2,2-dimethoxypropane, then only also we can convert this into this. Suppose we can write the mechanism for this. Suppose this is 2,2-dimethoxypropane, that is DMP. It is DMP. Okay, so if you are using this one, then the steps are, this is ONE OH. This is protonated, and we have, so this is converted into the good leaving group, that would be converted into good leaving group, and so this is moved out, and we have methanol outside, and okay, so this is positive charge over here. Now in next step we have a diol. So diol, it will this act as a nucleophile, and okay, so what we can write, we can OMe okay, so now okay. Now in next step, so we'll take over here another molecule of methanol, it will come out, and we have a cyclic dimethyl acetal, and the mechanism for the deprotection that remains same. Okay, so now in next one, and this 1,2-diol that can be converted into the cyclic carbonate. So let's see the second one as a cyclic carbonate, protection as a cyclic carbonate. Cyclic carbonate. Okay, so suppose if we have a diol, and this in presence of phosgene, and pyridine act as a base here. It will pyridine act as a base to remove this acidic H, and as well as to neutralize this HCl formed in this reaction. So here this chlorine will get kicked out, and what we can see, this OH, O, in next step, so HCl is removed, so H and this H and Cl is removed. Next step again, so this will attack over this center, and we will get a carbonate, cyclic carbonate. This is cyclic carbonate. Okay, and this can be deprotected with the help of by using KOH. In methanol, so this is deprotection step. Okay, so this may OH minus this nucleophile. Okay, O minus now. So in next step, the CO2 that is removed. So how this will come over here, and this will CO2 is removed from here, and what we will get, OH, and this O minus, this plus H plus, and this will be converted into diol. So this is protection and deprotection step for this. Now next one is we can convert it into cyclic silyl acetal. Okay, so if we have suppose diol, okay, so this diol in presence of dialkyl silyl dichloride. So suppose this R, this is equal to, or maybe this tertiary butyl group. Okay, so what we may get, so one of the HCl is removed. And next step, again this lone pair will go into this vacant d orbital, and this chlorine will leave out. Again this HCl will come out, and we will have a cyclic silyl acetal. So this is the cyclic silyl acetal, and this can be deprotected in presence of by using either TBAF or some fluoride source. HF is used as a fluoride source. So this is the step for the deprotection. So this fluorine, it forms a strong bond between this silicon and fluorine. Silicon strong bond is formed, whereas this silicon oxygen bond that will broken. Okay, and this H plus that will be formed. In next step again another so in next step another fluoride ion. So this is the step for deprotection. Okay. So these are some of the methods for the protection and deprotection of 1,2-diol. So in next lecture I will tell you the protection and deprotection for 1,3-diols. Okay, thank you.